So whenever people talk about digital night vision, they always claim that night vision is going to be good, or it's going to be competitive, or it's going to arrive in 3 to 5 years. Now, 3 to 5 years ago, we reviewed the SiOnyx Aurora in a video that you can watch somewhere on YouTube, and I think I even made a similar claim. So now, right on time, the SiOnyx Opsin has become available. So I'll save you the trouble of watching the entire review. I will tell you right now, thanks to the digital Opsin, or perhaps the 3 to 5 years, yes, digital night vision has arrived, but probably not for you, or possibly not for you. I'm gonna give you the 2 words that you love to see in every review. It depends. So we're gonna look at this device, and this will be a little bit of a longer video to go over all the things that it depends on. So we're gonna look at the device specs. We're gonna compare the Opsin device to the SiOnyx device from 3 to 5 years ago. We're gonna compare that to a high-end unfilmed L3 PVS-14, and we're going to look at footage from all of these different devices, and then we're going to go over the strengths and weaknesses of each. That's where your use case is really going to come into play. How these devices compare is the big question on everybody's mind, and then we're going to talk about who this thing is for. And then we're going to talk about the future. That's the part of the video that you probably don't want to miss. That's what comes 3 to 5 years after this thing. But possibly even sooner. So let's talk for a minute about the SiOnyx Aurora and the SiOnyx Opsin. The main weaknesses of the Aurora were it had a small sensor that was relatively low in sensitivity. The lens on the front was a little wonky at times, and the eyepiece on the back was not so great. The software did a million different features, but it was a little bit buggy, and there was latency inside of the thing that when you helmet mounted it, it contributed to some motion sickness, but only for certain people, like myself. The Opsin is a vast improvement on all of those fronts. The lens on the front is an improvement. The lens and eyepiece and viewfinder assembly on the back is great. It's actually a pleasure to use. The processor on the inside is considerably more powerful, even though it has fewer features. It, for the most part, does them more consistently and better, and the latency is essentially gone. So let's talk about the strengths and weaknesses of this device. Oh, but first we should talk about price, because that's what most people who are looking for digital night vision care about. They don't want something that's necessarily better. They want cheaper. I mean, they want better and cheaper. The most important thing, though, for them is price. So when this thing came out 3 to 5 years ago, it was approximately $600–700, depending on sales. There's a Pro version, and on eBay, these things are still $600 or $700. The price hasn't actually come down that much. And this device right here is $2,500, which is quite a bit more. 3 or 4 times more than this device, but does it actually offer 3 to 5 times more value? It depends. And then, of course, the obvious question is, how does it compare to a proper analog image intensifying tube inside of a PVS-14? These things are remarkably similar in their build, in their use cases, etc. Man, it is hard to say. You can definitely buy a used one of these for the price of this, and it's going to outperform it in a bunch of areas, but not all. And this device doesn't come just by itself. The $2,500 gets you the device, a battery pack, a cable, and an arm to attach it to a helmet. So it is a little more competitive than it looks, but you can see why I'm still saying it depends. So let's dive straight into the features and the capabilities of these devices. And we're going to use our trusty optical bench, which is now technically more than 3 to 5 years old. So to properly test all of these devices, we've got this bench here. This is the arm, the custom SiOnyx Opsin arm, and it's got a little bit of a sticky button here and lets you attach that. I have it temporarily attached to our testing bench. PVS-14 goes on here. All right, so this is the optical test bench that we've used for some of our previous videos. This is the Sony a7S II, which has been modified to be a full spectrum camera, sees infrared really well, and that's been in our previous videos about digital night vision and analog night vision. The SiOnyx Aurora the new SiOnyx Opsin, the PVS-14, and we're filming through the PVS-14 with this Sony RX100, so it's all manual settings, and it is about as consistent a setup as we can get. And let's talk primarily about these devices. With the feature set and the price range, these are the closest, these are the ones that you are actually wanting to see compared. But we'll show video from all 4 different ways of shooting so that you can really see what's going on. Now, the first thing that I want to point out, if you haven't watched our video on digital night vision, you should probably go check that out, because the difference between digital night vision and analog night vision is pretty fundamental. Obviously, they're trying to do the same things, look into the darkness and actually see images, but the way that they do it is so fundamentally, categorically different that you should understand that. We are not comparing apples and oranges here. It almost defies description. This is a magical chemical tube that uses a tiny amount of electricity to do essentially magic. And then this is a digital camera like the one that you have in your phone, just a little bit better at seeing in the dark. And their strengths and weaknesses are actually almost opposites. It's a little bit like, for example, a helicopter and an airplane. They both do the same thing, they both fly, but they fly in such totally different ways that the strengths of one are the weaknesses of the other. This is pretty much the same. So this device right here, the Opsin, has weaknesses in the areas of sensitivity. It is not as sensitive as this. It cannot see into the dark. When there is really, really, really low light levels, this thing struggles more than this thing does. So sensitivity is a weakness. Dynamic range is a weakness. It cannot see bright objects and dark objects that are next to them nearly as well as this can. The battery life is worse. The battery life on these things is insane because they're literally alchemical magic going on inside, and this right here just uses a lot of electricity to run the screen and the camera and the processor and the recording and the GPS and the compass and all the stuff that's inside. But I will say it's not terrible battery pack. We'll get into more of that later. The other thing that it's going to have an issue with is latency. Now, the latency is excellent, but this is a magic telescope. No latency whatsoever. As the photons come in at light speed, they turn into electrons at light speed, and then they come back out as photons at light speed, so no latency. And even though this is extremely minimal, I couldn't even figure out how to measure it. It was so tiny. I couldn't see it. It is still there. That is a weakness of this platform, not just this device. That is a weakness of this platform. But it has some strengths. It has some strength that this thing doesn't have. It can see in color. The sensor is more durable than the tube that is inside of here in certain circumstances. And it has that GPS and compass overlay that I mentioned before, and it can record. So that's really nice because it allows us to compare all of these devices really well. So let's dig into some of those strengths and some of those weaknesses. So it looks way better through the eyepiece than the actual recorded footage. That's kind of a problem for people who are reviewing the device and want to see exactly what it sees later, but it's less of an issue for people that are using this device in the field. The image quality coming out of these two devices is really similar on the recorded micro SD card, even though this thing looks way better through the eyepiece. And the same is true with the PVS-14. You are seeing a very close approximation to what it looks like. Just remember, this looks better in person, this looks better in person, this looks better on the screen, and then this thing is about the same. Even though this sensor is much higher resolution than 720p, it only records 720p, so you're losing some resolution, you're losing a lot of data in the compression, but even with that, I tried filming through the back, I tried recording and comparing the files, you can see that here, but you are getting a pretty good idea of the sensitivity of the device, even though you're not seeing the full resolution, you're not seeing the full quality. It's worth comparing. Most people want night vision so that they can have vision at night. And we filmed a bunch of tests at different times, but everything that you are seeing is pretty much a half moon with cloud cover. So it's not the worst case scenario of no moon. It's not the best case scenario of the full moon, which I think is totally cheating. You don't even hardly need night vision when that's happening. And even in that relatively favorable set of circumstances, the Gen 3 night vision, especially an L3 unfilmed tube like this, totally outperforms everything else on our current setup. There's just no question at all. But the Opsin has improved significantly over the Aurora. And when you go into a dark shed or the dark corner of an industrial building, you can actually see where all the devices begin to fail and how much performance they actually give you, how much visibility they get you into those dark corners, and hopefully that will give you a rough idea of how all of this stuff works. But the Opsin actually has another trick up its sleeve. Even though the sensitivity is not the same as this, in some ways it is actually better. Your eye can see visible photons from like 400 nanometers up to 700 nanometers, and then a night vision device like this PVS-14 can see all the way up to like 950-ish into the infrared spectrum. This thing sees all the way up into 1200. So even though it is less sensitive overall, it is sensitive to parts of the spectrum that this thing cannot see. And that is interesting because there are people building infrared illuminators and infrared lasers and infrared signaling devices and strobes and things that happen above that 950 nanometer range, specifically so that other people's night vision can't see it. And this does. That's kind of interesting. The other trick that it has up its sleeve is, of course, color. The ability to see in color is really, really interesting. And obviously, as the levels of light come way down, the saturation of the colors comes way down too. But a lot of times, being able to see things in color is kind of a big deal. It lets you separate different colors of lights, different colors of objects. You may not need that for your particular use case, but I can see police departments, forensic investigators, detectives, people like that really liking the ability to differentiate between colors. And the color sensor does another thing, which I've gotten totally spoiled by with the Aurora, and I miss it anytime I use analog, and that is the ability to see in color also means you can see the difference between visible light and infrared light. Infrared light has this very stark bluish purple, so it's really easy to tell the difference between an infrared light and a visible light through this thing, and it's just green through this. The easiest way to show this is if I throw out an infrared strobe, you can see the color of that infrared. It looks different than other colors. You can instantly tell if you were looking at an infrared light from a security camera, an infrared light from somebody's IR illuminator, and that is super cool in my opinion. Now, the other thing that strobe test is going to show you is that the dynamic range on this thing is not great. It really is having trouble with that light. You can see as it blinks on and off, the flaring in the lenses of all these different devices is a little different. This one's probably the worst, but that's because this is a vintage unfilmed 1.2 lens and it's got no anti-reflective coating whatsoever. The lenses are doing pretty well on all these, but the processing in here is just having a trouble with those super bright lights. And that becomes a bigger issue if you go out to drive. So oncoming headlights just completely blow out the image, make it really hard to see whether those headlights are coming from one car or several cars close together. And it makes it really hard to read road signs until you get really close. So depending on your use case, the environments that you're going to be in, what you actually are using this device for, that lack of dynamic range is a major factor. And an analog tube has much less of an issue with that, especially one that has manual gain right here. Now, I will point out that there is manual brightness over here on the side, but that controls the brightness of the screen, not the sensitivity of the sensor. Now, I love this because I actually like to run the brightness of the screen almost as low as possible so that I'm retaining as much night vision as possible in the eye that's looking through the thing. And there are some settings that you can access using these 3 buttons, which will turn the auto exposure down to lower levels, and I like to run those pretty low as well. But bright lights still kind of overwhelm this thing and make it harder to see what's going on in the image. Now, I've talked to SiOnyx about this. They think it's something that can be improved in firmware, so we'll see. So on the PVS-14, brighter environments are going to give you a much cleaner image. You're going to be able to see more data with your eye. But there's a significant downside to analog night vision tubes and bright lights. The tube inside is actually quite fragile. You can burn it by looking at too much light. And the newer tubes are more resilient. They're a little harder to burn than the others, but it is still something that you can totally cook and ruin by pointing at it too much light for too long. And this thing, no issues at all. You can look at the sun with this thing. It is not going to hurt it. You won't be able to see the sun very well, but no damage whatsoever to the unit. And I really think that is a huge, huge issue for a lot of different people. Now, I personally, I will admit, am a little bit paranoid about tube burn-in, and you should be too, because when you buy a $3,000 or $4,000 PVS-14 and you remove, like, I don't know, $2,000 or $3,000 of that value because you accidentally left it on pointed at a window, like, that is a huge issue. And as bad as burning out a $3,000 PVS-14 tube, burning out a $30,000 broadcast camera tube is worse. And I should know, because I have done both. The trauma of these events is burned into my brain just as much as these lights could be burned into this device if I left it on with the lens caps off for not very long just in here. So the fact that this thing is not sensitive to lights is a big deal. Now, you may be a very careful person, I'm sure you are. You may want to get this device because it is the peak of sensitivity and capability, and you will take great care of it and not damage it at all. Good for you. But if you are buying several night vision devices for other people because you are a police department or a sheriff's department or something else, and you know those guys are not going to take the best care of their equipment, the sturdiness of this tube is a huge, huge selling point. And for a paranoid person like myself, it's nice. It's a nice feature. Now, while we're on the fundamental differences in the way that these two very different types of technology work, we should talk about battery life. This thing lasts for weeks or months or years on basically no battery life, slightly exaggerating, but a AA battery or a CR123 will power this thing for hours and hours and hours, and that is just not the kind of performance that you're going to get here. There is no onboard battery on the Opsin whatsoever. You need to plug it into this battery pack, and using this fancy locking cable, which we'll talk about a little bit more later, you can get 8 hours of battery life through this relatively lightweight system right here. This is a proprietary battery, but it uses non-proprietary cables. It comes with its own charger, and based on my testing, it does indeed last for 8 hours. So it's not like this device doesn't have enough power to get you through a shift or to get you through a night. It just doesn't have the same power per weight and volume as a PVS-14. I think they've worked around the issue pretty well, but it's obviously there. It's worth noting. But doing night vision in a digital way gives you some significant upsides. Yes, you have to give a lot of power to the sensor and a lot of power to the processor and a lot of power to the screen that you are looking through. But that digital signal now can have information overlaid on top of it really, really easily. And that includes, with this device, time, compass, and GPS coordinates. And I've been working around navigation and GPS stuff quite a bit for the last couple of years, and I have come to appreciate GPS more, and I've come to appreciate compasses way more, specifically precise compasses. So this device's relatively imprecise compass is not as much of a value add for me as I thought it was going to be. So this compass gives you like 8 different directions, and that's super useful when you're driving. That's like the compass in your car. But when you're driving, roads, or at least intersections, are usually like right angles, so you don't need super accurate compass directions. But when you're out off-road in the field, you want to be able to dial in your direction to, 3 to 5 degrees at the worst case. So this compass is not going to be super useful for that. And the GPS, same deal. If you're already out in the field with GPS device, map, compass, you probably don't need the GPS in here quite as much as you think. I have GPS on my watch right now, so this is a little bit redundant for me. But again, if we go back to that police department, sheriff's department scenario, if I were a sheriff's department and I wanted to record everything the deputies are doing out in the field, this thing is going to record the GPS coordinates and compass headings that go along with those video files. So again, the video file isn't like cinema quality, and the compass isn't super accurate, but you have a record of exactly when and more or less exactly where and kind of sort of which direction people were looking at when they saw certain things. For departments, yeah, I think that's a super useful thing. But let's not get off the fact that the ability to overlay data on top of the screen is something that this device does more or less for free. So the future of digital night vision devices need to lean much more heavily into that overlay data, because that's something that this just cannot do easily. The only way that you overlay data on top of this device is with a tiny projector that sits around the front. And there are clip-on thermal devices and other heads-up display type devices that do that, and they do it relatively well, but it's a very finicky, expensive way to get digital data. And for here, it's literally just having it on the computer. It's like almost free. The latency in this device is almost transparent to me. I wore this thing for hours and I did not get motion sick, which for me is, this is a plus, this is a big win. There were a whole bunch of people when the Aurora first came out that bought these devices, which look a little bit like a toy camcorder, and immediately began 3D printing arms and mounting attachments so that they could run these on helmets. And they promptly went into the woods and threw up. No, I'm just kidding. Like only half of them threw up. Because the latency that's in here does contribute to motion sickness, and it affects some people more than others. So people were very eager to take this camcorder device, this handheld monocular device, and turn it into a helmet unit. And SiOnyx paid very close attention to that and made this device pretty much exclusively a helmet mount unit. There's no way to run it without plugging it into the battery pack, and it is built to match the form factor of PVS-14, and its mounting options are exclusive to their own arm that attaches to this helmet. Now, there's some confusion when it comes to latency. So this thing has a particular trick about it, and that is that it can adjust its frame rate. This thing has 3 different frame rates. It can run at 30 frames a second when you want maximum sensitivity. You can run at 60 frames per second, which is my personal favorite, and then 90 when you want to run and gun on the range like Lucas Botkin. You need those fast Twitch gamer speeds to actually be able to, you know, do the Lucas Botkin aimbot thing. But a lot of people have confused that with latency. The fact that because it's 90 frames a second, the latency is going to be 1/90th of a second, and it's more complicated than that. You're watching a video right now that is 24 frames per second, but the latency is like weeks, probably, from when this video is actually posted. Or maybe days, or maybe you commented first, and it's only hours. So the latency and the frame rate are not the same things. They're not really connected. You need to be able to measure both. And the latency on this is really, really good. It's transparent. It's not something that I figured out how to actually measure, and I decided I didn't need to measure something that was, for me anyway, immeasurable. But the frame rate matters. If you want to be able to move quickly and see things quickly, you need not only low latency, but you also need high frame rates, which is something that Lucas can talk about.
So this is the first digital night vision unit that I've been able to actually mount to a helmet and run around and shoot with. I've done quite a bit of shooting with analog night vision, PVS-31s, panos, thermals, PVS-7s, you know, old stuff, Gen 2, Gen 3, all of that. So I have quite a bit of time on analog. Being able to get on a digital device was, let's just say, interesting. Now, I haven't spent, you know, full nights and tons of hours and all that. It was mainly just a real quick, hey, run some tests, do some sprints, shoot some handguns, see if I can pick up my dot through this thing. How does the focus work? What do lasers look like? So I could kind of get an overall picture of what's going on. First off, this is still probably a couple generations or models away from being viable for running and gunning. As an observation device, if I were to wear this on a helmet and just pan and look around, and there's a decent amount of ambient light, so say a full moon or maybe sort of in the middle, definitely not like, you know, no moon at all. It could be used, it could be effective, but there's a couple things that I'd like to see change with this particular device for it to be head mountable really well. And the first is the weight of the unit itself is very close to a PVS-14. That's great. However, the battery pack that comes with it weighs quite a bit. This is like 11.8 ounces compared to a PVS-31 cold weather battery pack, which is at 7 with the cable. So you're looking at a battery pack that's pretty heavy. So in this case, with this battery pack on the rear of the helmet, it's actually not super balanced. It's actually pulling back more than it's pulling forward, which is typically what you have with night vision. So lightening up the battery pack would be really nice. There's a lot of play with the different mounting interfaces that are going on with the device, and I would love to see a stabilizing, a place for one of the stabilizing shock cords to connect into, or even both, to help prevent that from shaking and moving around as you're sprinting. Obviously the biggest issue is frame rate. This felt like playing an old video game that's capped at like 60 frames a second, but you have a supercomputer, is what it felt like shooting with it. But I was able to pick up a dot through the device. I was able to do, passive aiming. I was able to shoot. It was actually pretty cool because the reticle, the dot of my SRO was an orange color, so I'm not just shooting, with no color at all. I was actually able to discern color, which is pretty cool, but it is sort of in that pink night vision sort of color space. And there is a point there that I don't know how many people have brought up, but with digital night vision, and I want to test it more, IR lasers are actually harder to discern than with analog. And I think the reason for that is because you have so much color going on to distract from just the laser beam that you're dealing with that ends up looking sort of like a pink color. It's just a lot harder to see unless you're shooting a full power laser. It is much easier to see a civilian class IR laser through analog night vision than it is through a digital night vision unit like this. Now, as far as passive aiming goes, it's probably superior doing it with a digital unit, just because when you go to pull up that EOTech, you go to punch out that dot on your pistol, it looks very similar to that of that optic when it would be in the day. And I think that's really cool, but this is definitely a couple models away from being really viable, in my opinion, for being able to run and shoot with really fast. But it's definitely getting there, and I was able to sprint without throwing up at least a few times, and I was able to pick up my dot, actually shoot some things, and I thought that was pretty cool. So a couple improvements, being able to run stabilizing bungees, lightening up the battery pack, getting the frame rate up to 120 please or something higher, so like video games I play at like 170, would be really nice. That might actually be viable enough that won't cause nausea, vomiting, and you can actually discern things really quickly and turn your head nice and fast and see what's going on. So very cool. Those are some of my thoughts on this so far, and I'll turn it back over to Isaac.
One of the things that does bug me about the recording capability of this device is whether you set it on 60 or 90 frames per second, always records 30. So I originally thought we were going to shoot this video at 60 frames per second so that you could see the buttery smoothness. Only records 30. Again, this is not a huge deal. If you are doing anything other than a review of this device, you probably don't need all the recording capabilities, but that is what we're doing here. So Lucas's thoughts on this device are basically based on it being used as a head-mounted night vision replacement, and that is really what this is built for. Now is a great time to talk about the arm and the way that the arm works. This is a pretty standard style of arm with the connection here, the dovetail, Wilcox dovetail thing here. Throw it on there. Now, unfortunately, this thing does require some tools to adjust. If you want to change the interpupillary distance, you need a little tiny Allen wrench there. It's literally my least favorite size of Allen wrench. It's the one that you can round the corners off super easily. So I'm not a huge fan of that. Other than that, though, this thing is relatively good, solid, and it'll snap right in there. You don't really hear the click, but it is on there. So once you have this thing head mounted, it is pretty much like any other night vision device. The eyepiece is really similar to a PVS-14, but this is absolutely what this device is designed to do. So the question remains, who exactly was it designed for, and who exactly should buy it? Like I've said before, I think this is a phenomenal device, technologically speaking. I think that this demonstrates that digital night vision has arrived. It is extremely usable in a lot of circumstances, but very probably not for you. If you are looking for the capabilities of a PVS-14 and you are a viewer of the trex-arms YouTube channel, which I think is a relatively fair assumption for me to make, you probably want to buy a used PVS-14. You are a guy who wants one of these things, and you probably have the time to go onto air15.com and look at their used equipment and get a decent used PVS-14 to experiment with, and that will give you the maximum sensitivity, and it will give you the maximum capability that you are probably trying to emulate with all of the weaknesses that come with this particular platform. That is going to give you way better value for money than this device if your goal is to just do helmet-mounted night vision optic. But if you are a department, a police department, a sheriff's department, if you are paramedic, EMS, there's a lot of commercial and industrial usages where this actually makes a lot of sense. This would be cool, but this is expensive, and this is, again, relatively fragile. If you give this to untrained people, they will probably burn the tubes out relatively quickly. And The other thing is that there's not that many places that actually make night vision tubes, so they are relatively rare. If you want to go right now and buy 50,000 of them from L3, you probably can't, because Ukraine or somebody in NATO just bought a large batch. These things sort of trickle in and out, and the manufacturing of these things is probably very scalable. So for a commercial or industrial application, this thing makes a lot of sense. And my prediction is that we'll see a lot of these things get bought. Another thing that this thing has is no ITAR restrictions on it whatsoever. So if you're a foreign military, it is a pain to buy these things unless you have all your paperwork in order. If you are a foreign police department, don't even bother. But this thing right here is just a digital camera. There are no restrictions on it whatsoever. And obviously, SiOnyx has thought about that, because when you buy the thing, the charger that it comes with has like all of the different adapters for all of the different countries that, you know, have electricity. So it's a lot easier to buy this device. There are fewer options. It's not as confusing. It's available in larger quantities. There's no restrictions on shipping it anywhere. And it's far easier to use with minimal training. And in many ways, it's more durable. In some ways, the PVS-14 is more durable. Like you can scuba dive with this thing. Although, just a side note, if you are a trimix diver, you should know that helium can actually get in through the glass and soften the tube, but if you are a trimix diver, dives the night vision, probably already knew that. But in other ways, this thing is more sturdy. Lasers can still kill it, but lasers can kind of kill anything, so that's not necessarily a weakness. Now, I want to mention some considerations from a friend of mine named Nick Chen. Nick Chen is a phenomenal night vision journalist and researcher. He writes for the Firearm blog. He knows more about night vision than I do, and he's smarter than I am, and he is not very impressed with this device. And I agree 100% with his frustrations and his complaints. But I do think that people who are not Nick Chen and not me, and probably not the people who read the Firearm blog or watch our YouTube video, will like this device for all the reasons that I mentioned earlier. People that need to buy large batches and need to issue them to untrained people and don't want to deal with paperwork. Man, this is not terrible. And while you can go out again and get the used thing and get a used J-arm and pick up a Rhino mount or a Wilcox mount from a friend of yours because you go to gun shows and you have people who are interested in this stuff, I mean, sheriff's departments can't necessarily do that. And I think that this opens up a possibility for a whole bunch of people that never used night vision before to start considering it. So when I say that digital night vision has arrived, I'm not saying that this replaces these for guys who are already using these. I think digital night vision has arrived as a way for people who never had night vision before now consider using night vision because of this thing's strengths. And they don't care as much about its weaknesses because they're not already night vision people. Now, obviously, if you are a night vision person, this device is very cool, but it's also extremely frustrating in certain ways, little ways. Like I mentioned the PVS-14 eyepiece. Like, this is designed to look like one. It could have easily been one. Then I could have swapped eyepieces out, messed with optics, done different things that, you know, night vision geeks think are cool. And I mentioned that it comes with a battery pack and it comes with a cable, and that's cool because battery packs and cables are very expensive. That makes the $2,500 sticker price a little bit more manageable, but at the same time, you gotta realize that they gave you a pretty lame cable. This should really be a right angle connector because this sticks up and snags. I've been talking about this helmet for a while. I didn't even want to put this in while I was talking about it because of how much this sticks up. And the same thing is true for the locking collar connector that goes on the front here. If you line up the two white dots, it clicks together. It's a very high quality cable. I think this is made by Fisher, and this feels like a phenomenal locking connector here, very quality. But again, it should be a right angle connector. There's room for it, it works, but man, it's a frustration. And of course you can replace this thing, because it's not a proprietary connector, with a right angle connector, but that is a very expensive proposition that makes this thing cost even more money. And there's just a lot of other little things in here that bug me. Not because they completely defeat the purpose of this thing, is because we were so close to greatness. We missed it by this much. If we just had better connectors, if we had a better eyepiece, if we could record all the video that the sensor is capable of getting. Like, those are such little things, and it would have made this thing so much better. That is a slight annoyance. And you'd think that, like, maybe that demonstrates that SiOnyx, the company, is just kind of lazy, and they weren't paying very much attention to this product. But it's worth noting that SiOnyx got purchased by somebody else in the middle of development here, so that could also explain why a few things fell through the cracks. And I'm just impressed that the new owner of SiOnyx is interested in pursuing commercially available devices like this, because the other part of SiOnyx's business is sensor development. They build very high-end, very expensive sensors that they sell to military, industrial, complex style contractors, the prime contractors who are building drones, who are building all kinds of very cool night vision devices and sensors, remote robotic things, vehicle things, weapon things, and that is a pretty good business to be in if you can get those contracts. And I think that SiOnyx is actually doing a very cool thing by having that part of the business and also sell consumer devices directly to people like us, and let these devices and those sensors piggyback on the same research and development cost. Let the feedback from those guys and the feedback from people like us and people who bought the Aurora 3 to 5 years ago actually drive the development of their entire technology package. That is very cool, and I want to commend them for doing that. And that willingness to listen to other parts of the market is, again, part of the reason that these little frustrations just a little bit more frustrating. So if you are a night vision guy who thinks that some of this stuff is cool and thinks that the frustrations are frustrating and thinks that this is probably not for you, your next question is, when does digital night vision arrive for me? And the answer is, of course, in 3 to 5 years, like always. I think that for the next few years, this thing is actually going to sell really well. Not necessarily to guys like you and me, but definitely to people who are a little bit more professional in that commercial space. This isn't going to replace PVS-14s for people who are in the military. It might not even replace PVS-14s for like airsofters and folks. But I think that this thing is going to be used by a lot of different people. Again, specifically people who weren't using night vision before. This thing is going to change the landscape of night vision users, even though it's not necessarily changing the landscape of night vision devices. And when that happens, and SiOnyx has all these new customers and people look around and see that the interest in night vision is growing, that is actually going to drive some interest. It's going to drive some competitors, and that's going to drive some new models from SiOnyx as well. So I'm going to tell you a few things that I want to see, but also some things that I think that we should see in the future. So digital night vision needs to rely much more heavily on those strengths. It really needs to, I think, spend less time trying to overcome some of the weaknesses and more time trying to make the most of those strengths. The data overlay capability, the recording capability, the ability to have ruggedized sensors and multiple sensors being fed into the same display eyepiece. These are the things that I think are really important. The ability to have the data, like the GPS data and the compass data, but in a more usable, user-friendly way. Now, obviously, there's a ton of companies in Silicon Valley who are working on augmented reality, and they're doing very cool stuff, but most of them are pursuing augmented reality for the purpose of, like, photorealistic gaming, and I don't actually care about that. I don't actually want that for this device. I actually want something that is more like a 1980s fighter pilot's heads-up display.
Lock up, baby. Lock up. I got him locked. Bingo.
Not because I'm just, you know, really nostalgic for the first Top Gun movie.
This thing is so old.
But because I think that that's the right amount of information that you should be dealing with, and it's a pretty good format for it. So right here, I've been experimenting for a long time with different augmented reality displays, building semi-functional mock-ups so that you can see what I think might be useful, and I can experiment with different ways of doing things. And that's something that I would like to see, either in the next iteration of this or the next generation from a competitor. It's extremely doable. And the other thing that I want to see is additional sensor technology added. And I have a theory. My theory is that even if you have a relatively low quality CMOS image sensor, and it cannot compete with the capabilities of the PVS-14, once you add a relatively low sensitivity, low cost, low quality thermal sensor, you now have two sources of data that become greater than the sum of their parts. A handheld digital night vision monocular, which gives you thermal capabilities, is going to be really cool. There's a bunch of people that have played with different types of digital fusion. Digital night vision gives you the cheapest way to do the fusion and a ton of options depending on how much processing power that you have. You can use the thermal image to inform the visible image and vice versa in a whole bunch of different ways, a whole bunch of different modes that lets you see and do specific things. That adds a tremendous amount of value. And a lot of the drones that are on the market today, like the DJI-30T and the new Autel, they have multiple sensors inside of the drone head on the gimbal. So they generally have a telephoto high zoom lens, and then they have a really low light capable wide angle lens, and then they have a thermal camera, and then they have a laser rangefinder, which would be a phenomenal thing to add to a monocular or helmet mount device. And then you could do all kinds of really crazy cool stuff, theoretically for not that much money. So the thermal camera that's on there is $400 on Amazon. You probably couldn't exactly implement this for only $400, but that would make this thing $3,000, and that would not make it the most expensive digital fusion device on the market. It would make it kind of the only one. So that's what I'm excited about for the future. So all that stuff can come to the future of digital night vision devices, I think within 3 to 5 years pretty easily. And what it is that we're actually looking for in a night vision device is going to change, at least as much as the devices themselves. Now I realize that you want me to close this video out with a recommendation, a buy, don't buy recommendation, and you'd like me to say a little bit more than. It depends. But I think we've talked about the Opsin enough that you now know its strengths and weaknesses pretty well. You can decide whether or not it's something that is for you. And we've talked about some specific use cases to this one. But I would say after 3 to 5 years, it's obvious that this is still the winner in pure low light sensitivity and capability for a lot of different stuff like shooting and moving. This is actually still a pretty good performer when it comes to filming stuff at night or just having the capability of seeing into the IR spectrum. I carry this with me a lot of different places. I travel with it, and because it looks like a toy camcorder, no one has ever asked why I have this in my bag. It lets me see visible light and IR light at the same time and differentiate them. Like, this is a very cool little useful tool. I wish it were cheaper. It has held its value surprisingly well. And then for the filming side of things, the A7S II, which used to be the most expensive thing on this optical bench, believe it or not, it's now almost the cheapest. You can get this for $500 or $600 on eBay because it is obsolete and 6 years old, and then spend a couple $100 getting the sensor modified so that it can see into the infrared light, put a couple $100 lens on there. This thing is actually the winner when it comes to the recording capability. 4K, stabilized, not autofocus, not with this lens, but all kinds of manual controls. This thing is the one that has improved in value the most as the prices come down. And if you go back and you look at the comparisons, it still is really, really a high-performing thing. It even has better sensitivity than this in certain situations, but it does that by cheating. It has a gigantic sensor. You should not helmet mount this A7S II. So I guess I will see you in 3 to 5 years. We'll be looking at the next thing, but okay, actually another prediction. Actually, it's going to be less than 3 to 5 years. We'll be talking about another digital night vision device, possibly a multi-sensor device, possibly that adds new features and strengths, even if it can't overcome some of these weaknesses. I predict we're going to be talking about that in less than 3 to 5 years. So we'll break out the optical bench, drill some more holes, and see you then. I realize that's like the least fun kind of review. You either want a review that gets you really excited about a new thing that's worth owning, or is very witty and satirical about all the shortcomings of a terrible product. And this, I think, falls like smack dab right in the middle. So not the most fun for you guys, but you know, it was fun for me, and it's gonna keep being fun for me.